me record it, minimize my control panel so we can see. He's written some numbers and answers on here, some of which are correct, some of which aren't. Try to ignore his stuff and just look at the drawing.
Yeah, definitely.
Okay. So problem 20. Now, let me say something else.
Sure.
This whole, and I realized this just after our last session, that when you have circles and you're dealing with any combination of chords that intersect inside the circle, or secant lines that intersect outside the circle, or a secant line and a tangent line, like that.
Yeah.
All of the problems, you're either solving for the measurement of an arc in degrees, or you're solving for the arc length in inches, or you're solving for angles.
Okay.
So, like problem 20 is all about angles and degrees. There is no dimensions in problem 20.
Okay.
Okay? Whereas if we look in problem 24, it's the same thing. It's intersecting chords, but this is all about dimensions.
Right.
And this whole chapter is like that. We're either solving for angles and measurements of arcs and degrees, or we're solving for segment lengths.
Okay.
And these 8 problems demonstrate almost all variabilities of that. But essentially, what it means is that when you have a circle and you have chords, secant lines, and tangent lines, we can always figure out all the angles and measurements of arcs involved, and a lot of times we can figure out the measurements of segments.
Okay.
So it's kind of important in your mind that you distinguish between the two.
Yeah.
Okay? Now,
Okay.
this first problem is just 2 chords, and they give you that angle. And they want to know this. Oh, they also give you the measurement of this. Okay?
Okay.
So every one of these problems requires you to know the general formula. And it's different for every one. So there's like 8 general formulas you have to memorize.
Okay.
In general, if you have the intersection outside the circle, like this situation on number 26, it's going to be the difference. Well, no, that's not true. Let's take 22.
Sure.
Notice that the 2 secant lines intersect outside the circle.
Yeah.
That's going to be a difference of these 2 arc measurements.
Okay.
Times 1/2.
That makes
And
sense.
1/2 is involved in almost all of the general formulas.
Okay.
But if it's intersecting inside, then it's 1/2 of the sum of the 2 arcs.
Okay.
And that's almost a general rule. Well,
Right.
at least it's true for intersecting arcs inside, intersecting chords inside the circle. So what's the general formula that I can say? And when I talk general formulas and you look in the geometry book, they always start with the angle.
Okay.
Well, so let's start with that angle.
Okay.
What is that equal to?
Is it 105 plus x?
Yeah.
Divided by 2, yeah.
Well, it's always start, I'm convinced that you want to always start with the 1/2, not save it to the end and divide by 2.
Okay.
Now maybe that's peculiar to me, maybe that's the way I memorize it in my brain, and I think everybody should, and I may be wrong, because I notice that most all my students do it the other way. They do this part on the left side of the equation, and they put the 115 on the right. But if you go into the book and look at all the theorems, all of the theorems have the angle on the left side of the equation. And then put everything on the right.
Okay.
What goes on the right?
And then it's 105 plus x.
Okay. Let's solve that.
Alright, so 105 divided by 2 is...
Nah, let's not do it that way. Notice
Okay.
why. In other words, our first goal is to get rid of all the fractions. If we can turn this into nothing but whole numbers, it's a much easier problem.
Right. So we can multiply by 2 on each side.
Yeah, whereas if I got two choices, I can either multiply both sides by 2 or I can distribute this 1/2. But notice if I distribute the 1/2, all of a sudden this turns into 52.5 and this turns into 1/2 x. And now I have two denominators, not one.
Yeah.
So I suggest that you solve all equations by getting rid of the denominators first,
Okay.
then the parentheses.
Cool.
Well, if we multiply both sides by 2,
We get 230 is equal to
we get
210.
rid of both the 1/2 and the parentheses at the same time.
Mm-hmm.
That's what we're left with.
Okay. Would you multiply the parentheses by 2?
Well, no, here's what I did.
Is it just...
The first rule of algebra. You can do anything you want to one side of the equation as long as you do it to the other. So I multiplied the right side by 2 in order to have this 2 cancel with that 2.
Right.
You got to multiply the left side by 2.
Okay.
That's how I got 230. That 2 cancels with that, and
that makes sense.
I'm left with just 105 plus x.
Okay.
And now x is equal to 125.
Awesome.
So what you also discover is that this angle is the average angle between these two arcs that it intercepts. And let's look at it even closer. It's not just this angle that's 115. This one's also 115. They're vertical angles.
Okay.
So both of these angles are the average angle between the two arcs that are intercepted.
Okay.
So if you knew that, if you knew 115 was the average between 105 and something else, it wouldn't be that hard to come up with the 125. In other words, 115 is the average of 105 and 125.
Okay.
Okay.
Cool.
So that's intersecting chords. And you know what? Let's jump to problem 24.
Okay.
Because 24 is also intersecting chords, but it's only about the measurements. Now, there's no angles involved.
Mm-hmm.
It's strictly segment lengths.
Okay.
What formula can you write? What equation can you write here?
So you can do x times 6 is equal to 24.
Yeah. Equals 8 times 3.
Yeah.
And then x equals 4.
Cool.
Now, that's real simple to remember. One segment times the other part of the segment is equal to this segment times this segment.
Okay.
It changes when you get the intersection outside of the circle.
Mm-hmm.
In other words, if I have two secant lines like that, let's look at 26.
Sure.
That's 8, that's 5, this is x, and this is x plus 1.
Okay.
Now, here again, there's no angles. This is all about segment lengths.
Okay.
It turns out that if we wanted to solve for that angle, we know it's 1/2 of this arc minus this arc, right?
Right.
So that formula is still valid, but it doesn't apply here because they didn't give us any angles. So we have to go to our segment lengths. Now, this is completely different than the chords.
Mm-hmm.
The most common mistake people make here is they say 8 times x equals 5 times x plus 1.
Okay.
And that's not true.
That's not right, yeah.
No, what you get, what the equation is the part outside the circle
plus the
times
inside
the whole thing times the whole secant line.
times x
X
plus 1, right?
plus 8. This
X plus 8.
secant line
Oh,
right
I was
here
looking at the, okay. Yeah, I was looking at
has,
the other one.
has an x plus 8 length.
Yeah.
And that's equal to what?
And then that's equal to x times
X plus
1
1, the part
times
that's
5.
outside the circle, times,
Multiplied by 5.
not 5,
So just
the whole
just 1.
secant line. What's the
So
distance of the
it's
secant line from there to there?
6. Well,
X plus 6.
x
In
plus
other words,
6, okay.
isn't it 5 plus x plus 1?
Right, yeah, so it's,
Plus,
yeah, okay,
okay. So
yeah,
the difference between this and intersecting chords is significant. This is the
yeah.
part outside the circle times the whole thing equals the part outside the circle times the whole thing.
Okay.
And now we can solve that because that becomes x squared plus 8x equals x squared plus 7x plus 6. What's the next step?
So now we can subtract, or the x squares cancel out.
Good.
So it'd be 8x is equal to 7x plus 6, so 1x is equal to 6.
You got it.
Cool.
All right.
Awesome.
Let's look at problem 21. It's
Okay.
a little different. I'm going to draw it a little different too. I'm going to draw it like this.
Would you just do 360 minus 234?
Yep. That's the first step. In other words, if this is 234, we're trying to solve for this angle 1 right here.
Right.
In other words, this is a degree problem now. It's not a segment length problem. It's a degree problem. 360 minus 234, this arc has to be 146.
Cool. And then you just divide that by 2.
Yeah, and
Because,
if you forget whether you're supposed to, is it equal to 146 or do we divide it by 2? Well, this arc and that arc equals 360, right?
Yeah.
Well, what does angle 1 and angle 2 equal?
Angle 1 and angle 2 equals 180, right?
There's your answer, that you have to take half.
Right.
Because these two angles that total 180 intercept two arcs that total 360.
Yeah.
So angle 1 has to be 1/2 of 146.
Cool.
And angle 2 would be half of 234.
All right.
Each one of these problems is different. That's what I like about this.
Yeah.
Okay, so let's look at the angle problem with two, hold on, drew it wrong. The intersection takes place outside the circle.
Okay.
And this one we're trying to solve for angle 1. And they give us, this is 95 degrees, this is 85 degrees, and this is 175 degrees. So angle 1 equals what?
So angle 1 would
equal. Start with the general. Let me label some of these so we can talk about them.
Sure. So it's AB, or 1/2 AB minus CD.
Arc AB minus arc CD.
Yeah.
AB is 85. What's CD?
CD is just X.
No, you can figure out CD, and we need to.
Oh, yeah, so it'd be 85
if it was
divided by 2.
X, we don't know what angle 1 is. We'd have two variables then.
So it'd be 42.5. Right, because it's just 85 divided by 2.
No, this arc is not half of this arc.
No.
However, the whole circle is 360 degrees.
So you just do 360 minus 85.
No. The whole circle is 360 degrees.
Right.
Well, what part of the circle do we not know? The only part we don't know is CD.
Yeah.
Can you figure it out?
Yeah, you can just do 175 plus 85 plus 95,
Okay.
and then subtract that from 360.
Okay. What you get is 5.
Okay. Cool.
Now we can do 85 minus 5.
Cool.
In other words, we had to do another step before, like most geometry problems. Very few geometry problems are you going to solve in one step. Most of them are 2, 3, 4 steps. And this first step is figuring out what CD is. But you're not going to know that if you don't start with that general formula. In other words, the fact that I'm starting there, now I know, well, I know what AB is. I got to figure out CD. That's my first need, is to figure out what CD is. And I can do that because it's the only arc that's not accounted for. All right.
Okay.
Number 23 is also the same problem as 22. It's just that they make everything a function. This is now, we know this angle is 39 degrees. We know this arc is 7x minus 2 degrees. And we know this arc is 17x plus 6 degrees.
Yeah.
Now notice that every one of these problems that is a degree problem has nothing but degrees in it.
Yeah.
And every problem that is a segment problem has no degrees in it, like 24.
Just segments.
Just segment lengths. You won't see a degree sign there. I don't see a degree sign there. But in 23, I see nothing but degrees. 39 degrees, that has a degree on it, that has a degree on it. So we know we're dealing with degrees only here. What's 39 degrees equal to?
So 39 degrees is equal to 7x minus 2.
No.
Or,
start with 1/2.
1/2 AB minus CD.
What's AB?
17x plus 6.
It's always the big arc minus the little arc.
Yeah.
You can't, in other words, they're never equal. If I have two secant lines intersecting outside the circle, notice it's impossible for this to be bigger than this.
Yeah.
Can't do it.
No.
So it's always the bigger arc minus in parentheses, and the parentheses here are absolutely vital. If I don't use them, I'm going to get the wrong sign on this 2.
Okay.
What's the next step?
Multiply both sides by 2.
Okay, so now I got 78 equals 17x plus 6 minus, in parentheses, 7x minus 2. Now what's the next step?
We could combine like terms.
Getting rid of the denominators. What's the next thing you want to get rid of?
The parentheses.
Okay, let's eliminate this set of parentheses here. So what is it? 78 equals 17x plus 6. What next?
Minus 42x.
No, minus 7x.
Or minus 7x.
There's no multiplication going on.
Okay.
Is it minus 2 or plus 2?
It'd be minus.
No. I got to distribute that minus sign to both these terms.
So it'd be positive. 2 minus is equal to positive.
Right there.
Okay.
Okay, I distributed it to the 7x. That's how I got minus 7x.
Okay.
But I got to distribute it to the negative 2. That's why these parentheses were so important to put in. If I didn't put the parentheses in the first place, you'd have minus 2 here and get a completely different answer.
Okay.
Okay, now simplify.
So 78 is equal to 24x.
Minus?
I mean, 17 minus,
7x minus
so 10x. Yes, 10x plus 8.
Okay. I trust you know how to solve it from there.
Yeah, for sure.
All right.
Cool.
We did 24.
Uh-huh.
24 is probably the simplest problem on the page.
Probably, yeah.
Well, there's no way to get it wrong. In other words, you can't even make a mistake. You know it's x times 6 equals 3 times 8.
Yeah,
Whereas
exactly.
these problems like 26, you can easily make a mistake.
Right.
And most people do. Most people say x times 8 equals x plus 1 times 5, which is wrong.
Uh-huh. Right.
Okay? Let's look at 25.
Okay. Sure.
25 has a secant line, but it also has a tangent line.
Mm-hmm.
And there's no degrees. So this is a line segment problem.
Uh-huh.
Well, the rules on this are the same as they were for number 26. The part outside the circle times the whole line equals the part outside the circle times the whole line. It doesn't seem like it's the same, and your book actually attributes it to a different theorem, but you can always remember it by using the exact same rules that you would use on number 26. So what is the equation going to be?
So the equation is going to be 8 times x,
No.
or x times. Yeah.
That's the most common mistake everybody makes.
Okay.
It's not the outside times the inside.
Yeah.
It's the outside times the total.
Okay.
So it's x times what?
So it's x times x plus 8?
Yeah, that's the total length of that secant line.
Yeah.
And that equals 3, the part outside the circle. What's the total length of that tangent line?
11.
No, look at it. What's the total length? From there to there.
3.
Right. So it's 3 squared. And it's always squared. In other words, the way the book gives you this formula is that this squared equals this times the whole thing.
Okay.
But that's no different than the secant rule.
Yeah.
The secant rule was x times 8 plus x equals x plus 1 times 5 plus x plus 1.
Okay.
Well, this is actually, that's exactly what we're doing here. Taking x times the whole length, x plus 8, equals 3 times the whole length, which is 3. The whole length of the tangent line is always going to be the same exact thing as the part outside the circle, so it's always squared. And the formula they give is this squared equals this times the whole thing. But you can always remember it by remembering that it's the same rule as two intersecting secant lines.
Right. Okay.
Let's just practice a little algebra here. What's the line?
So x squared plus 8x is equal to 9.
And what then?
How would we do that?
Well, there's one key thing to remember when you're dealing with a quadratic. What is it? What's the most important thing you always do?
Isolate the x factor.
No, you can't.
No, you can't.
I mean, I could factor out an x, but I can't isolate the x. Well, not as long as it's in this format. If I factor out the x, this is what I get, and I can't solve that.
No.
Got two things multiplied together equal 9. Nobody can solve that.
No.
But what if I have two things multiplied together and they're equal to 0?
Oh, that's right. X squared is equal to 0. Or what was it?
If you want one side to be 0, then I got to move this 9 to the left.
Okay.
So, in other words, and that's what you always, almost always want to do with a quadratic. If you have a quadratic that has an x squared term, an x term, and a number, then always put them on one side and 0 on the other.
Okay.
Now, if I can factor that quadratic, I can solve the problem. because then I'm going to have two things multiplied together equals 0, and I can solve that.
Uh-huh.
The fundamental rule of algebra is if things are multiplied together and they're equal to 0, then one of them has to be 0. You can multiply 1/4 by 1/100th and get 0.
Right.
Has to be 0, has to be one of the terms. So factor this.
So it would be, let's see here. How could we use, so x.
First step, split up.
So x, yeah.
Always
in both.
Try to remember my method, really, because it's so simple. It really is.
Okay.
What's the second step?
So the second step is to find a number that...
No, that's the third. Everybody forgets the second step. It's because in the California method, it's so fakakta that they don't have the second step in the California method.
Okay.
What is the second step is determining both signs.
Okay. Yeah, that's right. So the first one would be plus, second one would be a negative.
They have to be opposite.
Yeah,
they have to be different.
Exactly.
Because you cannot produce a -9 if these signs are the same. If it's plus plus, that would be a plus, and if it's minus minus, that would be a plus.
Right.
So the fact that this is a -9 tells you for sure these signs have to be different.
Okay.
That's the second step.
Cool.
Now, the third step. What's the third step? Verbalize it.
So the third step would be trying to find two numbers that go into 8 and then add up to 9, -9.
No. Two numbers that multiply to 9. Right?
Okay.
In other words, if I had a 2 and a 7, well, this number is going to be -14.
Right. Yeah.
So at a minimum, they have to multiply to 9. They could be 9 and 1. That produces -9. But they have to be factors of 9 that do what?
That add to 8x. Or
subtract because of that negative sign.
Okay.
That subtract to the number 8.
Okay.
So what are the factors? 9 and 1, right?
Yeah, exactly.
Now there's a fourth step, because we have to figure out, does the 9 go with the plus sign or does the 9 go with the minus sign?
Right.
Which does it go with?
It goes x plus 9 and then x minus 1.
Goes with the plus sign because the middle term has a plus sign.
Yeah, exactly.
If the middle term had a minus 8x, then it would go with the minus sign.
Uh-huh.
So the larger of the factor goes with the sign of the middle term. So there's 4 steps and only 4 steps, and they're always the same.
Okay.
So it's not that hard to remember my method.
No.
First, break up the x's. Second, determine both signs at once. Third, find factors of the constant that either subtract or add to this number. And I don't mean plus 8, I mean just 8.
Uh-huh. Yeah.
All right, so what is our answer to this quadratic?
So it'd be x is equal to -9 and then x is equal to 1.
Okay, now the question is, are both of these possible? We're doing problem 25.
Yeah.
Are both of those answers possible?
I don't think so.
No. Can x be -9?
No.
No, because x is a measurement, not an angle measurement, but a length measurement of that segment right there.
Yeah.
Whenever you're doing dimensions, you cannot have negative dimensions. So when you solve a quadratic and one of the answers is negative, throw it out. But only if it makes a negative dimension.
Right.
It doesn't always. In other words, in 27, we could stand we couldn't stand a negative x. But there are some problems we've done where you can have a negative x because it doesn't make a negative dimension. In other words, if say this problem 26 was x plus 3 over here and x plus 4 there.
Okay.
And I went through the solution and I got an x of minus 3. Would that work? Yes.
Yeah, definitely.
Because it doesn't make a negative dimension. In other words, if one is x plus 4 and the other is x plus 5, well then if I got negative 3 for x, I still have a positive dimension there.
Yeah.
So it would be okay. In other words, it's not, you can't have negative x's, it's you can't have negative dimensions. And in problem 25, x was a dimension. So throw out the negative.
Okay.
We did 26. Let's do 27. 27 is basically the same as 25. There's no degrees. 25, we had a secant line and a tangent line. Well, 27, we have a secant line and a tangent line.
Yeah.
So tell me the formula. What's the equation that I need to write to solve?
So we would do...
Start with the tangent line, because it's always squared.
Okay. So it'd be x squared is equal to x minus 2, x like on the outside, right?
That's
or actually not the same side.
Now
and then x plus
higher secant line measurement.
And then x plus 2.
What's the length of this secant line? It's got 2 segments in it.
Right.
Add those 2 segments and you got the length of the whole line.
So 4.
No. Add these 2 segments. Let's start slow.
Okay.
X minus 2 is part of the segment. What am I adding?
And then x plus 2.
Okay. Now we'll simplify and see what we get.
Yeah.
X squared over there. I'm not going to multiply it until I take care of this part over here. What does that simplify to?
That simplifies to x cubed. Oh, x squared.
That's it. X squared.
Yeah.
2's go away. That minus 2 is canceled by that plus 2.
Yeah.
And it's not x squared. What's x plus x?
2x.
Yeah.
Yeah.
Now, it's a problem I can solve. It's got 1 variable in it. Let's solve it.
Okay. So it would be just x minus 2 is equal to x squared. Simplify. Oh, you're multiplying them, yeah.
X minus 2 by 2x.
Right, so it'd be 2x minus 4x.
2x squared.
Squared minus 4x, yeah.
Okay. Cool. In other words, you have to multiply that whole thing times x.
Right.
X times x is x squared. Okay. Now, how do we solve this?
So it'd just be x squared.
Okay.
X squared minus 4x.
0 equals x squared minus 4x. Now, notice this is a quadratic, but it's slightly different.
It is,
It doesn't
yeah.
have a number. It's only got an x squared term and an x term.
Okay.
But I still have 0 on the left side because the way I got this was subtracting 1x squared from both sides.
Yeah.
Well, can I factor that into the product of 2 things?
Yeah.
Okay, what is it?
So it'd be x plus 2 and then x minus 2.
No, that's not the difference of perfect squares.
So not.
Is there a greatest common factor you can take out?
16.
Greatest common factor has to be divisible into both terms. 16 doesn't go into x squared, 16 doesn't go into 4x.
Okay. So just x then? 2.
Just x, exactly.
Yeah, just x.
X is the greatest common factor you can take out. What's left over?
Yeah. So it'd be x X minus 2.
Is that equal to what we started with?
X squared minus, or it'd just be minus 4, my bad.
Always do that check.
Yeah, that
Because
did make sense.
everybody makes mistakes, but if you check every time you do a step, you'll realize you made the mistake right there and not when you get to the end of the problem.
Okay.
Okay, and you can correct it because it's so easy to see the mistake. If you multiply these back together and you don't get that, well then you got to do something different. And we did.
Yeah.
Changed it to x minus 4 instead of x minus 2. Now, what's the solution?
So now it would be...
Got two things multiplied together equaling 0.
Yes, it'd be x is equal to 0, and then x plus 4 is equal to 0.
X minus 4 is equal to 0.
Or minus 4, yeah.
So that makes x equal to 4.
Exactly.
Now, which of those solutions can I use? Problem 27.
The second one?
Yeah, I cannot have an x of 0.
No.
It would, first of all, you can't have a 0 dimension of a line that you can see doesn't have a 0 dimension. So immediately the fact that we see that as a positive dimension rules out that. Plus, if x was 0, this would be a minus 2.
Yeah.
Can't have that. But x of 4 works perfect.
Cool.
Okay. Now, the last part of chapter 10 is actually the easiest part. But you have to know the general formula for a circle. What is it?
Yeah. So it's x plus...
It's always
what is
minus.
X plus, or x minus h.
Minus.
Yeah. Squared, and then x minus k squared.
Plus.
Yeah, plus.
Y minus k squared.
Yeah. Is equal to r squared.
Right. The equation of a circle has both x and y in it.
Yeah.
Okay? So that's my general format. Memorize that. Don't ever forget it.
Yeah, definitely.
Okay? Well, here they give us x plus 7 squared. This is a specific circle.
X minus 4 squared is equal to...
Yeah, they meant y minus 4.
Oh, you're good.
Well, I'm good, but they're wrong.
Oh, yeah.
They meant this to be a y, not an x.
They meant y. Yeah.
Wouldn't make any sense. If it's x, it's not a circle anymore.
Yeah, exactly.
Okay? So it has to be y. And now they want to know the center and the radius of that circle. Hold on a second.
Sure.
Here.
Definitely.
What's the center of the circle? We know it's h and k. What's h?
So h is 7.
Really? If h was 7, then it would be x minus 7, wouldn't it?
Wait. Would it be h is minus 7 and then y is 4? Okay.
There you go. Not y is 4, k is 4.
Negative. Or k is 4, yeah.
In other words, that's k. That's not h.
No.
It's x minus h. But if h were minus 7, then we'd have x minus a negative 7, which we would end up with x plus 7. So if you have a plus sign there, it means h is negative.
Okay.
Okay, what's the radius of the circle?
So the radius, I've always been kind of confused on how to find the radius of this, so it's like...
If r squared equals 2, it does, right?
Oh, so the radius is 1.
No. How do I solve r squared equals 2?
Divide by...
No, if I divide by r, I'm going to have an r on the other side of the equation. And when you're solving equations, it's not just solving for r, it's solving for r and not having any other r's anywhere. In other words, it would be a natural mistake if I were to try to divide this by r, okay?
Yeah.
Because that is r. It looks like we've solved the problem. But we haven't, because we got an r on the right side of the equation.
Yeah.
So
Which
that's
is
not a solution.
no.
Got to have r equals nothing but numbers.
Okay.
So what else can I do besides divide by r?
Multiply it.
Well, that'd give me r cubed.
Yeah. Subtract it maybe.
Square root both sides.
Just square root both sides. Okay.
Well, what's the square root of r squared?
Just r.
Yeah, we've isolated it.
R is equal to root 2. Yeah.
Plus
Cool.
or minus, actually.
Plus or minus root 2.
Well, because
Okay.
whenever you solve an equation by taking the square root of both sides, the answer always begins with plus or minus.
Okay.
Okay? However, because we're talking about radius of a circle, you can't have a negative radius. So again, we can take away the minus and just leave this as the answer.
Okay. Cool.
And one more problem here. Let me blow it up so we can see it,
Sure.
because I can get to this problem earlier.
Cool.
Find the equation of the circle whose center is at -1, -3, and the radius is 5, and then graph it.
Okay.
I'm going to take away that. The center is at -1, -3. The radius is 5. So let's come up with the equation first.
Cool. So it would be x plus 1 squared plus k or plus y plus 3 squared equals 25.
Good. Very good.
Awesome.
Now, to graph that, where am I going to start?
Well, we know the center of the circle has to be 5.
Start with the center of the circle.
Okay.
There's two things about circles the only two things that matter. Where its center is and what its radius is.
Right.
So start with the center. Where's the center?
5.
That's the radius. Remember,
So
the center is right here. They gave it to us.
Oh, yeah.
That's how we came up with the equation, was they gave us the center. So if we go to this point, -1, -3, right there. Now all I have to do is draw a circle around that has a radius of 5. And I've graphed it. In other words, that distance has to be 5.
Awesome.
And that's it.
Cool.
In other words, graphing the circle is even easier than coming up with the equation of it. But see that for circles, it's really the only thing you need to remember is that general format for the equation of a circle.
Yeah.
As long as you remember that, you're not going to make any mistakes on these problems. These are the easiest problems in the world as long as you remember that general equation. And all conic sections, in other words, a circle is a conic section. They all are x minus h and y minus k. None of them are x plus or y plus. In fact, if you think about the equation for a parabola, that's also x minus h.
Yeah.
Plus k, but the only reason it's plus k is because that k started out on the left. In other words, what we really had was this.
Yeah.
So until you get to calculus, when you're dealing with h's and k's, they're always x minus h and y minus k. Doesn't matter whether you're dealing with parabolas, circles, ellipses, and hyperbolas. All conic sections are the variable minus h or the variable minus k. Never plus. In fact, short of calculus, there never is any situation where you're ever going to have an x plus h until you get to calculus, and then that is part of it.
Cool.
All right. Dylan, I'll let you go a little bit early here because
Sure,
we've gotten through all the problems.
definitely.
But these are a great set of problems. If you can do
Yeah,
these 10 problems, you're going to do well, I think, on any test that's covering Chapter 10.
awesome.
Now, you
Yeah,
got your semester final coming up here before too long. You should be
yeah,
getting a review packet for the entire semester.
should be. Yeah, I'm not sure when
Yeah,
he's gonna give it to us, but hopefully
well,
soon.
hopefully you get it tomorrow so that we can go over it Sunday night. But
That'd be
the
awesome.
sooner
Yeah,
you get it, the better, because
yeah,
we've been beating circles to death here. I mean, we've been doing
exactly.
circles for like 5 sessions.
Yeah.
And I think you
hmm
got them down pretty good.
I think so too. Yeah, yeah,
Like I said, if you can do these 10 circle problems, you got them down because every one of them is different from the other one.
right. Yeah,
And they kind of cover all of the situations that you encounter when you're dealing with circles and secants and chords and tangent lines.
yeah. hmm
All right.
Awesome.
Well, Dylan, good luck on your baseball games. And, man, if I get a chance to stop by, I might. And I
That'd be
make
awesome.
sure I
Yeah.
don't holler out, hey, Dylan, right as a ground ball's coming at
Oh, no problem. Yeah.
you. You wouldn't like
Awesome.
that.
Well, I appreciate that. Yeah.
Hey, batter, batter. Uh, oh,
Exactly.
gosh, even when I was coaching Little League, they used to joke about, hey, batter, batter.
Really?
I don't know if they still say that or not, do they? Are there still people in the dugout that say, hey, batter, batter? Just,
Not really. They just say,
I guess
keep your
that's an old
keep your
time,
chin in there and
that's an
hit the
old time
ball.
thing, I guess. I don't know.
Yeah.
It was
I
funny.
like that though.
It was
It's
funny back
old
then.
fun.
Yeah, you ought to try that sometime when the opponents are up to bat. Say, hey, batter, batter. Everybody will look at you like you're crazy. That's
Exactly.
from a previous generation. So,
Yeah.
anyway,
Awesome.
good luck on
Yeah.
your games, and I'll either
Thank
see
you.
you at the game or I'll talk to you Sunday night.
That sounds good. I'll see you either way.
Okay. Talk to you.
Alright, cool. Thanks, Mr. Cowan. Bye-bye.